The Supercat problem is a physics problem that I made up in my AP Physics class, so it can be solved with first year college physics. I made it up because I heard people talking about, like, what's your favorite physics problem? So I decided to make up my favorite physics problem. It's based on a lot of the free response questions on the AP test, which often have multiple parts, and to get the answer to a part, you have to use your answers from the previous parts. So this is the prompt. It has a little diagram here and some words. It says, a cat falls off a cliff of altitude A above a long spring with spring constant C. And you can see the spring is pretty long. It's almost as tall as the cliff itself. And A is the altitude of the cliff above the spring. So it's this distance here, how much higher the cliff is than the spring. And the mass of the cat is given in terms of A and C and G as well. It's 2CA over 3G. So part A asks, how long does it take the cat to reach the spring? And we can solve this using our basic constant acceleration equations. So what I like to do is start with the equation change in y is equal to the average velocity times the time. In this case, it's only change in y, because y is up and down. We don't have any change in x. The cat isn't going to go left to right. And so the change is going to be equal to the average velocity of the cat times the time that it takes the cat to reach the spring. So if you remember here that A is the distance between the top of the cliff and the spring, then the change in y of the cat is going to be equal to negative A, because it's going to fall downward that distance. And then the velocity, the average velocity with constant acceleration, can just be given by the initial velocity, v0, plus the final velocity, v subscript f, divided by 2, times the time. And then the final velocity will be equal to the initial velocity plus the acceleration times the time. So we can plug that in here and get negative A equals v0 plus v final, which is v0 plus at, all that divided by 2 times t. And we're in luck because the prompt says that the cat falls off the cliff, so we can assume that the initial velocity is 0. So I just plugged in some zeros wherever there was a v0, and I also plugged in, for the acceleration, negative g, which is the acceleration due to gravity. And when we simplify that a little bit, we get negative A equals negative gt squared over 2. Now let's continue over here. We don't need this anymore. So if we multiply both sides by negative 2, we can get 2a equals gt squared. And we can divide both sides by g because we're trying to solve for time here. 2a over g is equal to t squared. And then the square root of 2a over g, taking the square root of both sides, is equal to t. And of course, square roots have positives and negatives. Like the square root of 4 is positive 2 and negative 2. So this is going to be the positive square root, because negative time pretty much doesn't make much sense, right? It doesn't take the cat negative time to fall off the cliff. It's going to be a positive amount of time. And we should probably, yeah, that's good. So that's what the answer to A is right there, is the positive square root of 2a over g. Alright, so part B asks, what is the cat's velocity when it reaches the spring? And here I copied over our answer from A, because we're going to use that. The time it takes the cat to reach the spring is the positive square root of 2a over g. So the best way, or the way I like to do this, is to say the velocity is equal to the initial velocity plus the acceleration times the time. So the initial velocity we already determined is 0. The acceleration we know is negative g, and t, we know what that is because we just figured it out in part A. Da, 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 da. And then the way I like to do it, we can get rid of the 0, of course, and negative g times the positive root of 2a over g. A negative times a positive is a negative, so I just write it as negative g root 2a over g. And that's the answer. And of course the velocity is going to be negative because it's going down, and that's what negative velocity means. And I just wanted to mention that units are important, especially on the AP tests, at least as of 2016. But since these are using variables, we don't really know what the units are per se, so that's why I'm not writing the units. Yeah, because the prompt doesn't tell us what the units are. It doesn't mention anything about units. It just gives variables. So, yeah. So part C asks, how far does the spring compress after the cat lands on it? And this is kind of tricky because usually when calculating the compression of a spring, or the stretching of a spring, the spring is horizontal, so we don't have to worry about gravity, but this is a vertical spring, so we do have to worry about gravity. I think the best thing to do is probably use kinetic energy here. So we know that initial kinetic energy plus the work should be equal to the final kinetic energy. So 1/2 of the mass of the cat times the initial velocity of the cat squared plus the work by gravity on the cat plus the work of the spring on the cat should be equal to 0, because when the spring is completely compressed, the cat is going to have a velocity of 0, and so its kinetic energy is going to be 0. Now keep in mind that in this case, V0 isn't 0, because now V0 refers to the speed of the cat right as it hits the spring. So we can plug some stuff in here. 1/2, we know what the mass of the cat is because the prompt told us that it's 2ca over 3g. That's just what the prompt told us was the mass of the cat, so we can put that in. The initial velocity of the cat is going to be what we got for our answer in B. So that was negative g square root 2a over g. That was the velocity of the cat right as it hits the spring squared, plus work is the average force times the change in position. So for gravity, the work by gravity is going to be equal to the force of gravity, which is constant, times the change in y of the cat. The work by the spring is going to be the average force of the spring times the change in y of the cat, and all that is going to be equal to 0. And here we're going to be solving for delta y, because that'll be how much the spring compresses, or how much the cat sinks into the spring. So one thing we can do is just simplify a little bit right here. We'll keep the 1/2 and the 2c over this. When dealing with this term here, since it's squared, we can distribute the squared. So negative g squared is g squared, and the square root of 2a over g squared is 2a over g. The force of gravity we know is negative mg times delta y, and the average force of the spring is going to be equal to If we remember that the force of a spring is equal to negative kx. Well, in this case, the spring constant is c though, so it's going to be the force of the spring is negative cx. So the average force of the spring is going to be, and in this case, we're dealing with y because the spring is vertical. Sorry, so it's going to be negative cy. So the average force of the spring is going to be negative cy initial minus cy final divided by 2. Then we have all that times delta y is equal to 0. So with some simplification, we can keep this expression, 2ca over 3g, and we can multiply this 1/2 over here with this 2 over here so that they cancel out. And this can just be g squared times a over g minus the mass. Here I plugged in what the prompt said was the mass, times g times delta y. And here we have this negative cy naught. Get it? Why not? We can assume that y naught is right here and that this is equal to 0. And that way, delta y, the amount that the spring compresses, is going to be equal to the final position of the cat. So we can make this 0 and we can plug in delta y for y final. So this first term here has a g squared divided by g, and this expression is also divided by g. So all the g's are going to cancel out in this term, and we're going to have 2ac over 3 times just a. In this term, we have a g and a divided by g, so the g's are going to cancel out again. And this will just be 2ca over 3 times delta y plus, and what we can do here is get rid of the 0 and multiply the delta y by the delta y to get negative c delta y squared over 2 equals 0. And then with a little more simplification, here there are 2 a's, so we can simplify this term to 2ca squared over 3. This is the same thing, negative 2ca over 3 times delta y, and then minus c over 2 times delta y squared equals 0. We're actually going to need the Pythagorean theorem to solve this here. So we have the Pythagorean theorem is x, but in this case it's y equals negative b plus or minus square root of b squared minus 4ac all over 2a quadratic formula. So we have that there, and then we can plug in, or we're solving for delta y here. So delta y is equal to, b is negative 2ca over 3. Plus or minus the square root of b squared negative 2ca over 3 squared minus 4a. A is negative c over 2. C is 2ca squared over 3. And then all this is divided by 2 times a, which is negative c over 2. So we're gonna need to simplify this. Here the double negative becomes a positive. If we want to distribute the squared here, negative 2 squared is 4, c squared is c squared, a squared is a squared, and 3 squared is 9. And one thing that we can do here is there's a double negative, so it'll become a positive, and also we have a 2 divided by 2, so those can cancel out, and we can get plus 4 c times 2, not times 2 because that crosses out, times ca squared over 3. Divided by, these 2's cancel out, and we just get negative c as the denominator. What happened here is I left everything the same except this term here. We multiplied the c by the c to get 4c squared a squared over 3. Just more simplification. Again, if we want to add these two fractions, they have to have the same denominator. So we can leave that the same, and we can multiply this fraction by 3 on the top and the bottom. So on the top we'll get 12 c squared a squared, and on the bottom we'll get 9. Like that. One more step here. We add these two, and we get 16c squared a squared divided by 9. Just like that. More simplifying. We have the square root of this. Square root of 16 is 4. Square root of c squared is c. Square root of a squared is a. And the square root of 9 is 3. So the next thing we probably want to do is we have a plus or minus, so there could be two answers. Delta y could be equal to, if we add these, we get 6ca over 3, or and then over negative c. Or if we subtract these two, we can get negative 2ca over 3 over negative c. The only thing I'm going to do next is simplify the numbers on this one. Since 6 divided by 3 is 2, we can just say 2ca over negative c. And this one will just say the same. Or actually, you know what we can do? We can cancel out the negatives so that everything is positive. There we go. Now what we're going to do is cancel out the c's. C divided by c, this just becomes negative 2a. Or c divided by c, this just becomes 2a over 3. Now the question is, which one is it? Well, the change in the height of the cat, it's compressing the spring, right? So its change in position is going to be negative because it's going down. So we can know that delta y is equal to negative 2a because that's negative. Okay, so now we know that delta y is equal to negative 2a. And this is a little technicality, but the question was, how far does a spring compress? And since compression already implies negative, saying that the compression is negative would be a double negative. So the compression would probably be equal to the absolute value of delta y, or just 2a. And that would probably be the answer, because saying that the spring compresses 2a is basically saying that it goes down by 2a. Now, if you notice, that's kind of a weird answer in context. That's why I made the spring so long. The spring is going to compress by 2a. So here's a, the distance that the cat falls before it hits the spring, and then it's going to go down on the spring twice a. So the spring needs to be longer than twice a, which is a very long spring, or perhaps a very short cliff. I don't know. I like to imagine it as a long spring because this is Supercat. By the way, yes, I definitely did set the problem up so that the answer to C would be such a simple quantity. Alright, so, and then the prompt gives you something else. It says, when the cat stops moving, two things happen. One, the cat becomes gravity-proof and is no longer subject to the force of gravity. You'll probably never see that on the AP test because that can't actually happen in real life, so it might be kind of confusing. And two, the spring is disfigured by its contact with the cat, and the spring constant changes to c cubed a over 6g. So this spring constant was c originally, and now it's some expression in terms of c, a, and g. Now, when it says when the cat stops moving, what it means is once the cat compresses the spring as much as it's going to compress the spring. So the cat is going down, down, it's slowing down, and then for one moment it stops moving, and then the spring is going to start pressing the cat back up. So when the cat stops moving, the moment that the cat isn't moving is the moment that it goes as low as it's going to get. And question D asks, what is the cat's velocity as it leaves the spring? So we already solved for the cat's velocity when it reaches the spring, and then we figured out how far it's going to go down, how far the spring is going to compress. And then since gravity disappears, it's going to be very easy for the spring to push the cat back up. And then when the cat leaves the spring and continues going up through the air, we want to figure out its velocity. So the first thing I would do is use kinetic energy and work again. Initial kinetic energy plus work is equal to final kinetic energy. In this case, the initial kinetic energy is going to be 0, because the initial is going to be when the cat is when the spring is completely compressed and the cat is stopped. And so the cat has no velocity, so it's not going to have any kinetic energy either. The work is going to be, there's no gravity, so we only have to worry about the spring. It's going to be the average force of the spring times the distance that the cat travels. Now, delta y is a negative quantity. It's negative 2a. Delta y is the change in height of the cat when it's going down here. Now the opposite is going to happen, and the cat is going to travel the exact same distance, but this time it's going to go up, and then it's going to leave the spring. So the change in the height of the cat in this case is going to be negative delta y, because it's going to travel the exact same distance it did before, except up instead of down. And negative y is already, delta y is already negative, so negative delta y will be a positive. And then this should be equal to 1/2 the mass of the cat times the final velocity of the cat squared. And we'll be solving for the final velocity. Okay, we're going to use a little bit of physics here. Get rid of the 0. We know that the average force of a spring is, we'll go back to the force equals negative ky, because remember the spring constant changed, so it's not c anymore. So for right now, we'll just represent it by k. So the average force of the spring is going to be negative k y initial minus k y final divided by 2. Then we multiply by negative delta y, and that equals 1/2. The mass of the cat is still the same. The prompt told us that the mass of the cat is 2Ca over 3g, so we can plug that in. Alright, plugging things in. So, the thing told us, where is that other prompt? Yeah, it told us that now the spring constant is c cubed a over 6g. So we can plug that in here. Negative k, or not, we're plugging in for k. Negative c cubed a over 6g times y naught. Y naught is the position of the cat, which in the beginning is negative because the cat is at its lowest point. So we know what that is because we figured out delta y. It's negative 2a. Minus, and then y final is going to be 0 because that's when the cat leaves the spring. So we'll just say that's 0. Divided by 2 times negative delta y. Again, we know that delta y is negative 2a. Equals, what can we do here? We can multiply the 1/2 by the 2 on this side to cancel those out. And then we can just get equals Ca over 3g v final squared. So what I did here is a couple simplifications. First we have these two 2's cancel out, one on the top and one on the bottom, and then we have another 2 divided by 6, which is 1/3. So we can get this to c cubed a over 3g times plain negative a times positive a, because these two negatives cancel out. This side is the same. Then we can eliminate these two negatives to get a positive on this side, and there are 3 a's. C cubed times a cubed over 3g equals ca over 3g times v final squared. Now we can multiply both sides by 3g to get c cubed a cubed equals ca v final squared. And then remember, we're solving for v final. We can divide both sides by ca. So this will be c squared a squared, and this will just be v final squared. And then we finally got that v final is equal to the square root of c squared a squared, which is just ca. And remember, when we take the square root, it could be the positive square root or the negative square root. But as the cat leaves the spring, it's going upward, so its velocity is positive. And we know that c and a are both positive because c was the original spring constant, and a spring constant can't be negative. And the distance a was also positive. So that's the answer to D. And then there's one last part to this problem. Part E reads, if t equals 0 at the moment the cat leaves the spring, so the time is equal to 0, derive an expression for the height of the cat relative to the spring as a function of time. And here I just put y, the height of the cat, equals y initial plus vt. We know the velocity is constant because there are no forces acting on the spring, acting on the cat, since it's left the spring and it's still gravity proof. So there are no forces acting on the cat, so its velocity is going to be constant. Now, we want an expression for the height of the cat relative to the spring. Well, that would mean that its initial height is equal to 0, because they want us to find the height of the cat relative to the spring, meaning that the spring is 0, and everything we've dealt with begins where the cat is leaving the spring, and its height is at 0. So this is 0. The velocity, if we figured out, is ca, and then you just multiply by t, and very simply you just get cat. And I think this is kind of cool, because basically what's happening is the cat falls off the cliff, it reaches the spring, and it compresses the string by a lot. It's a really long spring, and it goes very far down on the spring, and then it becomes gravity proof because it's a supercat, and the spring pushes it back up, and after it leaves the spring with a velocity of ca, it just keeps going up with a velocity of ca.